What's up, everybody? Welcome back to Basic CHEM 101 with CHEM. My name is CHEM, and today we'll be dealing with the Hund's role. So let's get to it.
Let's go. This is for every child that wants to make it one day. Simple say class and presence of mind is elsewhere. Bring out also Granny, I've not moved already Alispani at the time I is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, they the written and focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, help me.
So as we continue with discussing the ground states of atoms, we haven't spoken about the electrons within each subshell. So here is what we know so far. We know that according to Pauli's exclusion principle, if we are doing orbital diagrams, so if this is Pauli, you know that the spins will be different. If you're doing the alpha or building up, you know that you will first feel the 1s, then you continue with 2s, then you go to 2p. You know that there is an order. You first have to feel this. Now if you have 6 electrons, you know that you're going to have 1s, 2s, then you have 2p. You know that you're going to have to fill up 1s, then you go to 2s, then you go to 2p. So if I have 6 electrons, the question is, how do I fill those electrons in the 2p? The alpha only tells me that I must fill the 2p now. It doesn't tell me how do I fill the electrons within the p subshell. So as either I can have 1, 2 electrons, or I have 1, 2 electrons, or I have 1, 2 electrons. So in that case, I do not know how to fill the p orbital. So that is where the Hund's rule comes in. Remember that we are trying to fill electrons to the ground state so that we get the lowest energy possible. So the Hund's rule tells us that in order to achieve the lowest energy, we have to spread out the electrons in different subshells before we pair them. So this means the actual way of filling electrons, if you're looking at 6 electrons, you will follow the half-Paul's principle, which is the 1s first, the 2s first. But when you get to the 2p, or when you get to subshells that have more than 1 orbitals, what you have to do, you have to spread the electrons out first before you can actually pair them. So in this case, you have to spread you only have 2 for the 2p, so you have to put 1 here, and then you are done. Let's say you had and oxygen has 8 electrons, right? So you will have 1s, 2s, 2p. So this would be this. Of course, principle is obeyed. Now we get to we have 4 electrons. So you spread out the electrons in different subshells, and then once you are done, that is when you can actually pair them after that. So the Hund's rule, it goes like that. Now, if you understand your Hund's rule, this will help you understand also the magnetism of certain atoms. Okay, so let's look at magnetism, right? So what we're saying is, when electrons are paired, the net magnetism of those electrons is zero because they cancel each other out. But when they are unpaired, there is a magnetism that is found there. If we take an example of what we have already spoken about, if we have 6 electrons, that would be coupled. So you would have your 1s, 2s, and 2p. And then Hund's rule, or all the rule that we have spoken about. So, and also if you have oxygen, so if this is your carbon and this is your oxygen, you have unpaired electrons both. So there is a net magnetic field in both of these. So if you put a magnetic field or a large magnet near an oxygen atom or a carbon atom, these would be weakly attracted by the magnetic field. Then if you look at, let's say, beryllium has 4 electrons, which is 1s, then 2s, 2p has nothing. So you have only paired electrons for beryllium. So this one would be weakly repelled by a magnetic field. Now, if your atoms are weakly attracted by a magnetic field, they are known to be paramagnetic, which means there are unpaired electrons in your orbital diagram. And then if they are weakly repelled by a magnetic field, it means they are diamagnetic, which means you have only paired electrons. So that is the Hund's rule and explaining of how it applies to the magnetic field. So for today we stop there, and that is how we will be wrapping up the electron configurations and the orbital diagrams. So please don't forget to subscribe. Don't forget to share the video, and thank you very much for watching. This has been Basic CHEM 101 with Sihle. My name is Sihle, and I will see you on the next video.